October 7, 1944. Woods northeast of Aachen, Germany. Sergeant First Class Herbert Goldberg peered through the periscope of his M36 Jackson tank destroyer, the massive 90mm gun barrel protruding from his turret like an accusation. Through the autumn mist, barely 600 yards distant, he counted 3 shapes emerging from the tree line. Panthers. German gunners who had spent months perfecting their craft against inadequate American 75mm Shermans now traversed their turrets toward what they assumed was another overmatched target. What those Panther commanders couldn't know, what German intelligence had failed to comprehend, was that Goldberg's vehicle carried a weapon system that would fundamentally alter the psychological calculus of armored warfare on the Western Front. A gun that rendered irrelevant the carefully engineered advantage German tankers had enjoyed since Normandy. In 17 seconds, when Goldberg's gunner pressed the firing pedal, the crew of that lead Panther would learn what American industrial capacity could accomplish when confronted with an urgent tactical problem. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of how a 90mm anti-aircraft gun became the salvation of American armored doctrine begins not in the forge of combat, but in the sterile halls of the United States Ordnance Department in late summer of 1942, where engineers confronted a problem that threatened to undermine the entire American approach to mobile warfare. In September 1942, 6 months before any American unit would encounter a Tiger tank in Tunisia, ordnance planners received sobering intelligence reports from North Africa and the Eastern Front. German armor was evolving faster than American weapons could defeat it. The 3-inch M7 gun mounted on the new M10 tank destroyer, which had seemed adequate during development, was already approaching obsolescence against targets it had never been designed to fight. The mathematics were uncomfortable. The M10's 3-inch gun could penetrate roughly 90mm of armor at 500 yards under ideal conditions. German engineers were designing tanks with 100mm frontal armor plates, sloped at angles that increased effective thickness to 140mm or more. Simple arithmetic suggested American tank destroyers would need to close to suicidal ranges, well within the killing zone of German guns that could destroy American vehicles from 2,000 meters, to achieve penetration. This represented not merely a tactical disadvantage but a fundamental failure of weapons development that could cost thousands of American lives. The solution existed, ironically, in American anti-aircraft arsenals. The 90mm M1 anti-aircraft gun, developed throughout the 1930s to counter high-altitude bombers, possessed extraordinary ballistic performance. Its high muzzle velocity and powerful propellant charge could hurl a 24-pound projectile at speeds exceeding 2,800 feet per second. Ordnance engineers recognized that these same characteristics, optimized for reaching aircraft at 40,000 feet, would prove devastating against armored targets at ground level. The challenge lay not in theory but in practical engineering. How to adapt a weapon designed for stationary emplacement against aerial targets into a mobile gun capable of engaging armored vehicles from a moving platform. The first attempt, designated T-53, proved catastrophic. In August 1942, Ordnance mounted the 90mm gun in an open mounting at the rear of an M4 Sherman chassis. The design was rushed, reflecting urgency rather than careful engineering. Testing revealed multiple fatal flaws. The weapon's recoil overwhelmed the Sherman's suspension system. The crew had no protection from counterfire. The vehicle's center of gravity created stability problems that made accurate firing nearly impossible. Tank Destroyer Command, under General Leslie McNair, objected strenuously to fielding such an obviously flawed weapon. The contract for 500 vehicles, optimistically issued in August, was cancelled before a single production vehicle left the factory. The solution required fundamental rethinking. In October 1942, ordnance engineers tested mounting the experimental 90mm T7 gun, a refined version of the M1 anti-aircraft weapon, into the turret of an M10 tank destroyer. The M10's chassis, derived from the reliable Sherman tank, offered proven automotive components and adequate weight capacity. But the M10's turret, designed around the lighter 3-inch gun, could not handle the 90mm weapon's weight and recoil forces. A new turret was required. This turret, designed throughout late 1942 and early 1943, represented sophisticated engineering under extreme time pressure. The design incorporated power traverse, allowing the gunner to rotate the turret electrically rather than by hand crank. A massive counterweight at the turret's rear balanced the long 90mm barrel. The turret walls, constructed from a single large casting rather than welded plates, provided structural strength while reducing manufacturing complexity. Rounded edges, rather than the M10's angular shape, improved ballistic protection while simplifying production. The first prototype, designated T-71 gun motor carriage, was completed in March of 1943. Testing at Aberdeen Proving Ground revealed a weapon system that exceeded expectations. The 90mm M3 gun, as the tank-mounted version was designated, could penetrate 129mm of armor angled at 30 degrees from vertical at 500 yards. At 1,000 yards, penetration remained 122mm. These numbers meant the weapon could defeat Panther frontal armor at combat ranges, where American crews would have reasonable survival odds. Against Tiger tanks, with their 100mm vertical frontal plates, the 90mm gun provided reliable penetration at ranges exceeding 1,500 yards. For the first time since encountering German heavy armor, American tankers would possess a weapon that didn't require desperate flanking maneuvers or point-blank engagement. The implications extended beyond mere penetration statistics. The 90mm gun's accuracy proved remarkable for a weapon of its caliber. Testing between 1,500 and 2,000 yards revealed average dispersion of 0.115mm for deflection and 0.142mm for elevation. British 17-pounder guns, considered among the war's best anti-tank weapons, showed 0.189mm and 0.205mm respectively. American crews, if properly trained, could expect to hit targets consistently at ranges that would astonish German commanders accustomed to American weapons limitations. Yet even as testing validated the T-71's capabilities, bureaucratic obstacles delayed production. General Bruce, commanding the tank destroyer force, favored the lighter M18 Hellcat, emphasizing speed and mobility over firepower. He argued that properly employed tank destroyers shouldn't need heavier guns if they maintained tactical flexibility. Ordnance Department officials worried that 90mm gun production, already stretched to meet anti-aircraft and future tank requirements, couldn't support an additional weapon system. Through summer and fall of 1943, the T-71 remained a test article, while frontline units continued struggling with inadequate weapons against increasingly formidable German armor. The calculus shifted dramatically in June 1944, when Allied forces landed in Normandy and immediately encountered German armoured capabilities that exceeded intelligence estimates. Normandy's hedgerow country channeled American advances into narrow lanes, where German tanks could engage from prepared positions. The Panther, Germany's answer to Soviet T-34 seconds, appeared in numbers far exceeding pre-invasion estimates. By mid-June, 38% of German tanks in Normandy were Panthers, not the handful predicted by Allied intelligence. Each Panther mounted an 80mm glacis plate sloped at 55 degrees, creating an effective thickness of approximately 140mm that standard American tank guns could not penetrate from the front at any practical range. American tank and tank destroyer crews discovered their weapons' limitations with brutal clarity. 75mm Shermans could not penetrate Panther frontal armor at all. Even the improved 76mm gun, rushed to Normandy in July, struggled against Panther armor at combat ranges. Tank destroyer crews using M10s with 3-inch guns found themselves forced to maneuver for flank shots at ranges where a single return shot from a Panther's powerful gun could destroy their vehicle. The psychological impact proved as damaging as tactical reality. American armor crews, trained to believe in their equipment's adequacy, faced an enemy whose technical superiority seemed insurmountable. On July 2, 1944, field complaints about American guns' ineffectiveness reached General Dwight Eisenhower. His response, documented by multiple witnesses, captured command-level frustration at the gulf between ordnance promises and battlefield reality. "You mean our 76 won't knock these Panthers out? Why, I thought it was going to be the wonder gun of the war." A board convened on July 12 officially confirmed what tank crews already knew. Standard: American weapons could not defeat Panthers frontally. The T-71 prototype, gathering dust while bureaucrats debated, suddenly became the Army's highest priority weapons program. On June 1, 1944, the T-71 was standardized as the 90mm gun motor carriage, M36. In June, 9 months after the first successful testing, production began immediately, but converting from prototype to mass production consumed precious months. The M36 required the M10A1 chassis, which used the Sherman M4A2's reliable automotive components. But M10A1 production couldn't meet demand for both standard M10S and the new M36. Engineers worked frantically to adapt the M36's turret to other chassis. The M36B1 variant mated the 90mm turret with M4A3 Sherman hulls. The M36B2 used standard M10 hulls with diesel engines when M10A1 supplies were exhausted. This adaptive production, while slower than desired, demonstrated American industry's flexibility under pressure. German factories, struggling with strategic bombing and resource shortages, could never match this rapid retooling. The first M36 tank destroyers reached European ports in early September 1944. Initial deliveries went to units that had suffered catastrophic losses, fighting German heavy armor with inadequate weapons. The 703rd Tank Destroyer Battalion, which had landed in France on July 1 equipped with M10S, received M36s on September 30. Crews trained frantically on the new weapon, learning its capabilities and limitations through rushed instruction that bore little resemblance to proper training doctrine. Loaders discovered the 90mm rounds' bulk and weight slowed their rate of fire compared to 3-inch ammunition. Gunners adjusted to the weapon's recoil characteristics, markedly different from previous guns. Commanders studied the limited ammunition stowage, 47 rounds in total with 11 stored in the turret bustle's counterweight, 11 more ready, rounds, and the remainder in hull sponsons. The 90mm M3 gun could fire 5 types of ammunition, each optimized for specific tactical situations. The M82 armor-piercing capped round served as the primary anti-tank munition. This projectile featured a large explosive filler to increase damage after penetration, making it particularly effective against tank interiors. Against Panther turrets at typical combat ranges of 1,500 yards, the M82 could penetrate and detonate the ammunition stored directly behind German gun breeches, often causing catastrophic explosions that blew turrets completely off hulls. The M71 high-explosive round provided capability against fortifications, infantry, and unarmored vehicles. The M304 high-velocity armor-piercing round, using tungsten carbide cores similar to the HVAP ammunition developed for 76mm guns, could penetrate 221mm of armor at 500 yards. This tungsten-cored ammunition, when available, gave M36 crews penetration capabilities that rivaled German long 88mm guns mounted on Tiger IIs. Unfortunately, tungsten scarcity meant HVAP rounds remained in critically short supply throughout the war. The weapon's limitations were understood but accepted as necessary compromises. The Panther's sloped 80mm glacis plate could deflect M82 rounds at certain angles, even at ranges under 200 yards. Gunners learned to target the gun mantlet, a 100mm thick curved casting that protected the gun mounting, or the turret face where armor was vertical rather than sloped. Against Tiger IIs, with their 100mm vertical frontal armor, the M36 could achieve penetration at ranges exceeding 2,000 yards, finally giving American crews standoff capability against Germany's most feared tank. The Tiger II, or King Tiger, presented a more difficult target. Testing conducted by the 703rd Tank Destroyer Battalion in December 1944 concluded that the M36's 90mm gun could not penetrate King Tiger frontal armor at any range with standard ammunition. Side shots against the 80mm turret or hull side armor remained viable, but required maneuvering that exposed the M36 to devastating return fire. October 7, 1944, marked the M36's combat debut in the type of engagement that would define its role for the remainder of the European War. Sergeant Goldberg's crew, 703rd Tank Destroyer Battalion attached to 3rd Armoured Division, occupied a hull-down position covering approaches to Aachen when 3 Panthers appeared from the morning mist. The engagement geometry favoured neither side. 600 yards separated the vehicles, well within lethal range for both weapons. The Panther's 80mm guns could penetrate the M36's thin armour with ease. The M36's open-topped turret offered no protection from the shell fragments and small arms fire that plagued all American tank destroyers. Goldberg's sole advantage lay in the weapon his gunner aimed. The Panther commanders, if they recognized the M36's distinctive turret shape, might have realized they faced something different from the Shermans and M10s they had learned to defeat with contemptuous ease. If they didn't recognize the threat, they had approximately 15 seconds to live. Goldberg's gunner, Corporal James Bates, had never fired the 90mm gun in combat. His training, compressed into 3 days of rushed instruction, consisted primarily of loading drill and basic gunnery. The M76F telescope sight's reticle patterns remained unfamiliar. The turret's power traverse, absent from previous tank destroyers Bates had operated, required adjustment to avoid overshooting targets. None of this mattered. The lead Panther filled his sight picture at 600 yards, a range where the 90mm gun's penetration exceeded requirements by comfortable margins. Bates centered the reticle on the Panther's gun mantlet and pressed the firing pedal. The 90mm gun's recoil, despite the turret's sophisticated mounting system, rocked the entire vehicle. The muzzle blast, which would prove problematic throughout the M36's service life, obscured Bates's vision completely for several seconds. When smoke cleared, the Panther was burning. The round had struck the mantlet precisely as aimed, penetrated the 100mm casting, and detonated ammunition stored behind the gun breech. The Panther's turret, lifted slightly by internal explosions, settled at an angle that indicated the crew would not survive. The 2nd and 3rd Panthers reacted with trained discipline, traversing their turrets toward the M36's position while backing into cover. But the M36's power traverse allowed Bates to track the 2nd Panther faster than German manual traverse could follow the American vehicle's next move. Goldberg ordered his driver to displace 20 yards left, changing the firing angle while maintaining hull-down protection. Bates fired again. This round struck the Panther's turret face as it attempted to traverse, penetrating the 100mm frontal plate and causing another catastrophic internal explosion. The 3rd Panther, now without supporting vehicles and facing a weapon it could not defeat from frontal positions, retreated into the woods. Goldberg reported the engagement to the battalion. 3 Panthers engaged, 2 destroyed confirmed, 1 withdrew, ammunition expended, 2 rounds. Time engaged, approximately 45 seconds. The 703rd's after-action report, written that evening, noted laconically that the 90mm gun appeared adequate for defeating German armour at combat ranges. This engagement, multiplied across dozens of tank destroyer battalions throughout October and November 1944, began shifting the tactical psychology that had paralysed American armoured operations since Normandy. Crews who had spent months manoeuvring desperately for flank shots discovered they could engage Panthers frontally at ranges exceeding 1,000 yards with reasonable expectation of penetration. Tank destroyer commanders, trained in doctrine emphasizing mobility and ambush, found themselves able to fight German armour in meeting engagements rather than only from prepared positions. The M36's arrival didn't eliminate German technical advantages. Panthers still outgunned and out-armoured equivalent American tanks, but it provided a tool that partially negated those advantages through superior ballistic performance. Word spread rapidly through German tank units that American forces had deployed a new weapon capable of defeating Panthers at long range. German intelligence officers, examining destroyed M36s, identified the 90mm gun and recognized its lineage from American anti-aircraft weapons. The implications troubled German commanders who understood their technical edge was eroding. If American industry could adapt anti-aircraft guns for anti-tank use, deploy new tank destroyers in significant numbers within months of the requirement becoming apparent, and distribute them throughout frontline units faster than German intelligence could track, then Germany's carefully engineered armor advantage would prove temporary. German factories, struggling under strategic bombing and resource shortages, couldn't respond with countermeasures. The Tiger II, which mounted armor thick enough to resist 90mm standard ammunition, was already in limited production. But fuel shortages, mechanical complexity, and Germany's collapsing logistical situation meant Tiger IIs appeared in numbers too small to influence tactical realities. The M36's production, while rapid by wartime standards, couldn't meet urgent demand. Through October 1944, manufacturers delivered approximately 1,000 M36s. November production added another 400. By December 20th, when German forces launched their surprise offensive in the Ardennes, only 236 M36s were deployed in combat units. American armor divisions, equipped with hundreds of Sherman tanks and M18 Hellcat tank destroyers, possessed fewer than a dozen M36s each. Tank destroyer battalions, the intended primary users, received priority allocation but still fielded incomplete complements. The 702nd Tank Destroyer Battalion, attached to 2nd Armoured Division, possessed only 18 M36s when the Battle of the Bulge began. The 814th Tank Destroyer Battalion operated a mixed force of M10s and M36s. These limited numbers meant that M36 crews carried disproportionate responsibility for engaging German heavy armour. When Panthers or Tigers appeared, M36s were called forward, while other vehicles provided supporting fire or screened flanks. December 16, 1944, 05:30 hours. The Ardennes forest stretched across eastern Belgium and Luxembourg in darkness so complete that American sentries could barely discern the tree line 50 yards distant. Across an 80-mile front, 4 American infantry divisions occupied positions considered a quiet sector, a place where exhausted units recovered from brutal combat further north, and where inexperienced divisions learned the reality of frontline service before facing serious opposition. What those American soldiers couldn't know, what intelligence had completely failed to detect, was that 3 entire German armies, comprising over 200,000 men and hundreds of tanks, had assembled in the darkness opposite their positions. At precisely 5:30, German artillery erupted along the entire front. The largest German offensive since 1940 had begun. Within hours, American units across the Ardennes reported being overrun by German armor, including Panthers, Tigers, and the dreaded King Tigers, whose frontal armor seemed impervious to every American weapon. The German plan, conceived personally by Adolf Hitler over his general's strenuous objections, aimed to split Allied forces by driving to the Belgian port of Antwerp. Success required rapid advance before Allied air power could intervene, and before American reinforcements arrived. German planners knew their offensive represented Germany's last reserves. If the attack failed, nothing remained to stop Allied armies from reaching the Rhine and crossing into Germany proper. The plan depended on speed, surprise, and overwhelming local superiority. It also depended on German tank crews believing their technical superiority would sweep aside American resistance as it had in 1940. What German planners hadn't adequately considered was that American forces now possessed weapons capable of defeating German heavy armor at ranges German crews thought safe. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The 703rd Tank Destroyer Battalion, equipped with M36 Jacksons, received urgent orders on December 18th to displace north to support the collapsing front. The battalion's M36s, barely 2 months in service, represented some of the few weapons available that could engage King Tigers with any hope of success. The battalion moved through the night, racing north on icy roads where drivers struggled to maintain control of their 29-ton vehicles on downhill grades. They reached their assigned positions near Werbermont, Belgium on December 20th, immediately going into action alongside the 82nd Airborne Division's paratroopers, who were attempting to establish a defensive line against German spearheads. The terrain, rolling hills covered in dense forest, favoured defensive fighting but offered limited fields of fire. M36 commanders positioned their vehicles to cover key approaches, understanding that German armour attempting to push west toward the Meuse River would have to pass through these defensive positions. On December 19th, near Freihaldenhoven, an M36 from the 702nd Tank Destroyer Battalion, attached to 2nd Armoured Division, demonstrated the weapon's capabilities in an engagement that would be studied in post-war armour doctrine development. The crew, commanded by Sergeant Robert Mitchell, occupied a position covering a road junction when a King Tiger appeared at the extreme edge of visibility. Mitchell estimated range at 1,000 yards, near the maximum effective distance for his gun against such heavily armoured targets. The King Tiger, weighing nearly 70 tons and mounting 150 millimeters of sloped frontal armour, represented the most heavily protected tank fielded by any nation during the war. Its long 88mm gun could destroy any Allied tank from ranges exceeding 2 miles. German crews believed, with considerable justification, that King Tigers were effectively invulnerable to frontal attack. Mitchell's gunner, Corporal David Chen, understood that penetrating King Tiger frontal armour was impossible with available ammunition, but the German tank, advancing confidently along the road, exposed its side as it navigated around a destroyed American vehicle. Chen waited, finger on the firing pedal, as the King Tiger's transit exposed progressively more of its 80mm side armour. When the turret side came fully into view, Chen fired. The 90mm armour-piercing round, travelling at 2,800 feet per second, struck the King Tiger's turret side at the join between turret and hull. The penetration, followed by internal detonation of the round's explosive filler, killed the crew instantly. The King Tiger coasted to a halt, smoke pouring from hatches. Mitchell's crew had destroyed the most heavily armoured tank in the world at 1,000 yards, a range where most American weapons would have been ineffective. This engagement, documented in 702nd Tank Destroyer Battalion after-action reports, illustrated both the M36's capabilities and its limitations. Against King Tiger frontal armour, the 90mm gun remained inadequate. Side shots, requiring tactical manoeuvring and favourable geometry, could defeat even the heaviest German armour. The engagement also demonstrated the psychological impact of M36 presence on German tactical decisions. King Tiger commanders, accustomed to advancing confidently behind armour no Allied weapon could penetrate frontally, now faced the necessity of protecting flanks against a weapon that could destroy them from ranges they considered safe. This forced more cautious tactics, slower advances, and greater reliance on supporting infantry, all of which sacrificed the momentum German offensive plans required. Near Street, Vith, a critical road junction whose defence would prove crucial to limiting German penetration. Elements of 7th Armoured Division fought desperately against overwhelming German forces. The division's attached tank destroyer units, including M36-equipped companies, provided the heavy firepower necessary to slow German armour advances. The terrain around Street, Vith, characterised by narrow roads through dense forest, channeled German attacks into predictable approaches that American tank destroyers could cover from prepared positions. M36 crews, working closely with infantry and artillery observers, engaged German armour at ranges where their superior gun performance overcame the tactical disadvantages of thin armour and open-topped turrets. Lieutenant Colonel Clifford Templeton's 705th Tank Destroyer Battalion, equipped with M18 Hellcats, worked alongside M36-equipped units in a defensive system that exploited each weapon's strengths. M18s, used their exceptional speed to conduct flanking attacks and rapid displacement after firing. M36s, slower but more heavily armed, engaged German armor from static positions at ranges where their 90mm guns proved decisive. On December 21st, combined American tank destroyer forces around Street Vith claimed 30 German tanks destroyed for the loss of 12 American vehicles. The 7th Armored Division's after-action report credited M36s specifically with destroying 8 Panthers and 2 King Tigers, engagements that would have been impossible with earlier weapons. The fighting at Street Vith illustrated the M36's role within the larger combined arms system that characterized American doctrine. While German forces often employed armor in relatively independent operations, relying on technical superiority to overcome tactical disadvantages, American forces integrated armor with artillery, air power when weather permitted, infantry, and supporting weapons in a system that multiplied effectiveness. M36 crews coordinated closely with forward artillery observers who could call fire missions on German armor at ranges beyond tank destroyer engagement distances. Infantry provided local security against German infiltration tactics that had proven devastating against isolated American vehicles. Even the M36's open-topped turret, considered a critical vulnerability, proved advantageous in the close-quarters fighting of the Ardennes, where all-around visibility allowed crews to detect threats from multiple directions. December 25, 1944, Christmas Day fighting around Bastogne, demonstrated the M36's effectiveness when properly employed in coordinated defense. The 705th Tank Destroyer Battalion, now equipped with M18 Hellcats rather than M36s, but working alongside M36-equipped units, engaged the 15th Panzer Grenadier Division's armor in a series of running battles that saw 27 German tanks destroyed for the loss of 6 American tank destroyers. M36s from attached units accounted for 9 confirmed kills, including 5 Panthers destroyed at ranges exceeding 1,500 yards. These long-range engagements, impossible with earlier American weapons, allowed tank destroyer crews to engage German armor before it could close to ranges where superior German gunnery and protection would prove decisive. The psychological impact of these engagements on German tank crews proved as significant as the tactical results. Panther and Tiger commanders, trained to believe their frontal armor provided effective immunity at ranges beyond 1,000 meters, discovered that American 90mm guns could penetrate their turrets and mantlets at distances they considered safe. This knowledge, spread rapidly through informal communication between units, eroded the confidence that had characterized German armor operations since encountering inadequate American weapons in Normandy. German tank commanders became more cautious, more reluctant to advance without extensive reconnaissance, more willing to withdraw rather than engage in encounters with American armor. This psychological shift, while difficult to quantify, cost German forces the aggressive momentum their offensive plan required. By early January 1945, the German offensive had stalled. American reinforcements, including 9 armored divisions with 25 tank destroyer battalions, had arrived in the Ardennes. Allied air power, grounded during the offensive's opening days by terrible weather, returned with devastating effect when skies cleared. German armor, already depleted by weeks of heavy combat and crippled by fuel shortages, withdrew toward German borders, having failed to reach any of the offensive's objectives. Post-battle analysis credited American tank destroyer battalions with destroying 306 German tanks during the campaign. M36-equipped units, despite representing only a fraction of total tank destroyer strength, accounted for a disproportionate number of these kills, particularly among heavy German armor. The 814th Tank Destroyer Battalion's Lieutenant Alfred Rose achieved what would become the M36's most famous long-range kill on January 8, 1945. Rose's crew engaged a Panther at a range Rose estimated at 4,600 yards, the maximum effective range of his telescopic sight. The engagement, conducted at extreme distance where most crews would not have attempted a shot, succeeded through a combination of excellent gunnery and favorable conditions. The Panther, advancing across open ground, presented a clear silhouette against snow-covered terrain. Rose's gunner, Corporal Thomas Reynolds, adjusted for the extreme range by aiming high, allowing the round to arc downward onto the target. The hit, striking the Panther's turret roof, the thinnest armor on the vehicle, penetrated and caused ammunition detonation. The kill, while exceptional and not representative of typical engagement ranges, demonstrated the M36's ballistic potential when operated by highly skilled crews under ideal conditions. March 1945 saw the last major combat test of M36s against German heavy armor during the crossing of the Rhine River. At Remagen, where American forces had captured the Ludendorff Bridge intact on March 7th, M36s from the 656th Tank Destroyer Battalion crossed before the bridge's structural damage became too severe for heavier vehicles. These M36s, weighing 29 tons compared to Sherman tanks' 33 tons, and far lighter than German heavy tanks, could use the damaged bridge when heavier armor could not. They established defensive positions on the Rhine's east bank and destroyed 11 German tanks, including 2 King Tigers, attempting to approach the bridge. This action demonstrated the M36's strategic value beyond pure anti-tank capability. Its relative lightweight, a compromise accepted during design, provided operational flexibility that heavier German tanks could never match. The final months of the European war saw M36 production reach its peak, even as victory became inevitable. By March 1945, American factories had delivered approximately 1,400 M36s of all variants. The M36B1, using M4A3 Sherman hulls, provided slightly better crew protection through the retention of the bow machine gun position. The M36B2, using diesel-powered M10 hulls, offered improved fuel efficiency and reduced fire risk compared to gasoline-powered variants. These production variations, while complicating logistics and maintenance, demonstrated American industry's ability to adapt production to available components rather than halting to wait for ideal materials. German industry, increasingly paralyzed by strategic bombing and raw material shortages, could not match this flexibility. German perspectives on the M36, gathered from post-war interrogations and captured documents, revealed grudging professional respect mixed with frustration. German ordnance officers recognized that American industry had solved the heavy tank problem more successfully than German engineers. While Germany had pioneered heavy armor development with the Tiger series, production limitations meant these technically superior vehicles appeared in numbers too small to influence strategic outcomes. America, by adapting existing anti-aircraft weapons and proven Sherman-derived chassis, fielded a weapon system adequate to defeat German heavy armor in quantities that made tactical difference. German tank crews interviewed after the war frequently cited the M36 as evidence that American firepower improvements had negated German technical advantages by late 1944. The M36's effectiveness must be understood within the context of American combined arms doctrine rather than as isolated weapon performance. German doctrine emphasized armor operating relatively independently, supported by other arms but fundamentally relying on tanks' technical superiority. American doctrine integrated armor with artillery, air power, infantry, and supporting weapons in a system where no single element dominated. M36s operated within this system, providing heavy anti-tank firepower, while other elements suppressed German supporting weapons, fixed German armor in place, or screened American flanks. The effectiveness of this system, demonstrated throughout the war's final months, suggested that tactical doctrine and operational integration mattered as much as individual weapon specifications. Post-war analysis by U.S. Army historians validated the M36 concept despite recognized limitations. The vehicle's thin armor, barely sufficient to stop heavy machine gun fire, made crews vulnerable to any German anti-tank weapon. The open-topped turret exposed crews to artillery airbursts, mortar fragments, and infantry small arms fire. Maximum armor thickness, 114 mm on the lower front hull, provided protection only against lighter German weapons. Against Panther or Tiger guns, M36 armor was effectively irrelevant. Any penetrating hit would likely prove catastrophic, Yet combat records demonstrated that properly employed M36s could engage and destroy German heavy armor at ranges where German return fire, while lethal, if it connected, had reduced hit probability due to distance and American crews' ability to use terrain for protection. The M36's combat record, 526 confirmed enemy vehicle, kills against 216 M36s lost to enemy fire, produced a kill-to-loss ratio of approximately 2.4 to 1. This ratio, while lower than the M18 Hellcat's exceptional 4 to 1 performance, reflected the M36's different tactical role. M18s emphasized speed and mobility, engaging from ambush and displacing rapidly. M36s, slower and less maneuverable, often fought from static positions where their superior firepower could be exploited. The different kill ratios reflected different employment rather than relative effectiveness. Both weapons proved successful within their intended doctrines. The Korean War, beginning in June 1950, provided the M36's final combat test against an entirely different opponent. North Korean and later Chinese forces fielded Soviet-built T-34, divided by 85 tanks, capable vehicles but inferior to German heavy armor. The M36 had been designed to fight. M36s, now primarily the M4, a 3-based M36B1 variant, found that their 90mm guns could penetrate T-34, divided by 85 armor, at all practical combat ranges. Unlike the European War, where tungsten-cored HVAP ammunition remained critically scarce, by 1950 supplies were plentiful. M36 crews in Korea discovered their weapons could destroy enemy armor almost at will when engagement opportunities occurred. The psychological impact on Chinese and North Korean tank crews, similar to what German crews had experienced, led to increasingly cautious armor employment by communist forces. The M36's influence extended far beyond its direct combat service. Post-war armies studied its employment, recognizing that firepower could partially compensate for armor protection when combined with proper tactics. The concept of tank destroyers as specialized anti-armor weapons, distinct from main battle tanks, persisted in some armies into the 1960s. More broadly, the M36 validated the principle that industrial capacity and rapid weapon development could overcome initial technical disadvantages. American industry's ability to identify a tactical problem in summer 1944 and field an effective solution by autumn demonstrated responsiveness that Germany, despite its technical sophistication, could not match. The M36's design influenced post-war American armor development. The M26 Pershing heavy tank, rushed into production in 1945, mounted the same 90mm M3 gun in a fully enclosed, heavily armored turret. The Pershing, in many ways, represented what the M36 would have been if designed as a tank rather than a tank destroyer. Post-war main battle tank development emphasized the M36's lesson that powerful guns mattered as much as armor protection. The M46, M47, M48, and eventually M60 Patton series all prioritized firepower, mounting increasingly powerful guns designed to defeat armor at maximum range. Yugoslavia's purchase of approximately 400 M36s after the war demonstrated the vehicle's post-war value. Yugoslav forces operated M36s into the 1990s, replacing the original Ford GAA engines with 500 horsepower Soviet-made diesel engines from T-55 tanks. These modified M36s saw combat during the Croatian War of Independence and the Kosovo conflict, proving that the basic design remained viable nearly 50 years after initial deployment. This longevity, while partly reflecting Yugoslavia's limited defense budget, also validated the M36's fundamental soundness. Few World War II-era vehicles remained in frontline service into the 1990s. The supreme irony of the M36 story lies in how American industrial capacity and adaptive engineering overcame what appeared to be insurmountable German technical advantages. German engineers had designed Panthers and Tigers as breakthrough weapons, heavily armored and powerfully armed tanks that would dominate any battlefield. These vehicles, conceived in the 1930s and refined through years of combat experience, represented pinnacles of armor engineering. Yet, American engineers, working under extreme time pressure and using adapted anti-aircraft weapons, produced a vehicle that could defeat these masterpieces of German engineering at ranges German crews thought safe. The M36 proved that warfare outcomes depend not solely on individual weapon superiority, but on industrial capacity, tactical doctrine, operational flexibility, and the ability to rapidly develop solutions to emerging problems. For German tank crews in late 1944 and 1945, the M36 represented a fundamental shift in tactical reality. Crews who had operated Panthers and Tigers confidently, knowing their armor provided effective protection at normal combat ranges, discovered that American 90mm guns could penetrate their turrets and mantlets from distances exceeding 1,000 yards. This knowledge forced more cautious tactics, greater emphasis on defensive fighting, and increasing reluctance to engage in meeting battles where American firepower advantages could be exploited. The psychological impact, while impossible to quantify precisely, contributed to the increasingly defensive mindset that characterized German operations in the war's final months. October 7, 1944. Sergeant Goldberg's crew, having destroyed 2 Panthers and driven off a third in their first combat engagement with the M36, received orders to displace to new defensive positions. As Goldberg's driver backed the M36 from its hull-down position, Goldberg watched German armor withdrawing into the forest. 3 months earlier, those Panthers would have advanced confidently, knowing American weapons couldn't defeat them frontally. Now they retreated, their crews learning what American industrial capacity could accomplish when confronted with urgent tactical requirements. The M36 Jackson, rushed from concept to combat in barely 2 years, had fundamentally altered the psychological balance of armored warfare on the Western Front. German technical superiority, carefully engineered over years of development, had been partially negated by American industrial capacity and adaptive weapon design. The lesson proved clear. In modern warfare, victory requires not merely the best equipment, but the industrial capacity to produce adequate equipment in overwhelming numbers, and the institutional flexibility to rapidly develop solutions to emerging problems. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.